All right, so hopefully the internet decides to cooperate today and we can get through this. So we have Unit 1, Lesson 7. We're finishing that up today, and then you'll have a review for tomorrow and Wednesday. And then you'll have your first test on Thursday, Friday. I'll open it up on Thursday, and then you'll have until Friday at midnight to complete it. So lesson 1.7 is on solving linear systems using matrices. So the essential question is, how can matrix row operations be used to solve a system of linear equations? At the end of this unit, we'll solve systems of equation using matrices. So the basic idea of matrix row operations is very similar to what we did in 1.6, where we were solving systems of linear equations. Now you're just doing it in a matrix. So you still can multiply, you can still add rows, you can still subtract rows, you can still multiply or divide a row, just like you could with linear equations. So row operations can be applied to a matrix to create an equivalent matrix. So there are 3 basic row operations. You can switch rows. So basically row 1 can become row 2, row 2 can become row 1. And that's all you do is you just switch the numbers. You can multiply or divide elements of a row by a non-zero constant. So I can multiply by 3, I can multiply by 1/2 or divide by 2. I can add elements of a row to or subtract them from elements of another row. So I have A and I wanted to this first row and I wanted to subtract the second row. A minus D, B minus E, C minus F. The second row stays the same. So you can replace one of the 2 rows you just combined. So if we take a look at a couple of examples. All right, so example 1, it's understanding row operations on a matrix. So I want to know what the solution of the system of the linear equations is. The first thing that I want to do is I want to set this up, this the set of linear equations as a matrix. Okay. So 3x minus 2y equals 25. So I just take the coefficients in front of the variables. So 3, -2, 25, and 2, 5, 4. Okay. Now, normally I would multiply this by this first equation by 2 and the second equation by 3. Okay, I can do the same thing with my matrix. So I multiply the first row by 2, the second row by 3, which gives me 6. So the first row by 2 is 3 times 2 is 6, -2 times 2 is -4, 25 times 2 is 50. And then the second row by 3, 2 times 3 is 6, 5 times 3 is 15, and 4 times 3 is 12. Does everyone see how we got this matrix right here?
Yeah.
So then I want to replace row 1 with row 1 minus row 2. So basically I'm just subtracting the 2 rows. Okay. So when I do that, 6 minus 6 gives me 0. -4 minus 15 is -19. And 50 minus 12 is 38. And then I'm going to divide row 2 by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. And 12 divided by 3 is 4. Now I want to divide row 1 by -19. Okay. What I'm basically doing here is I'm getting this variable by itself. I want this to be 1. Okay. So 0 divided by -19 is 0. -19 divided by -19 is 1. 38 divided by -19 is -2. Everyone good so far?
Yep.
Okay. All right, then I want to multiply row 1 by -5. Okay. So 1 times -5 is -5, and -2 times -5 is 10, because I'm trying to get this value over here by itself. So when I do that, I want to add row 1 and row 2 together. So I get 0 plus 2 is 2, negative 5 plus 5 is 0, and 10 plus 4 is 14. Okay. Now I can divide row 1 by negative 5 and row 2 by 2. So I get, when I divide by negative 5, I get 0, 1, negative 2, and then dividing row 2 by 2, I get 1, 0, and 7. I can then switch rows, so row 1 and row 2 are switched, so x is 7 and y is negative 2. I can then check by substituting 7 and negative 2 back in and solving to make sure that they're correct. So they are correct when I substitute them back into both equations. So the solution of a system of linear equations is 7, negative 2. Does anyone have any questions on what we did? Okay. So I can then try the try it problem. What is the solution of each system of linear equations? They do want you to solve this as a matrix. It's fine for me if you want to solve it using what you know. You can do that as well. I'll actually work it out as a system. So there's actually a calculator in Desmos that lets you do pretty much whatever you want with these. So 2, negative 5. Column. That's going to give me 11. And then 4, 3. So here is the matrix based off of the linear equation. So you can actually go through and you can solve this. So like I could multiply the first row by 2, which would give me 4, negative 10, 22, and then I could subtract them. Also though in Desmos, if you click on RREF, which stands for Reduced Row Echelon Form, and then type in the letter of the matrix that I created, it gives me a reduced row echelon form. So it tells me that X is 3 and Y is negative 1. There's that calculator for you. You can use this calculator on any of your tests because you'll have a graph, like an actual graphing calculator for keystones or anything like that that has to deal with this. So you will be able to use a calculator like Desmos or like a graphing, like a TI-73 or a TI-83. They all have this capability of doing reduced row echelon form. So you can absolutely solve this system of equations longhand. You can change it into a matrix and solve it that way. You can substitute that into a calculator and do reduced row echelon form, RREF, and it will give you the answer. So X equals 3 and Y equals negative 1. You can always substitute, even when you put it into a calculator, always double check that your values work when you substitute it back into both equations. Because things happen. You can mistype something in a calculator. You can, miscalculate something if you're doing it longhand, anything like that. So always double check that your solution actually works in your system of equations. So I can do the same thing for this one. So I have 3, negative 4, and negative 18. So I'm going to go ahead and create a new matrix. I'm going to add a column, so I have 3 columns. So I have 3, -4, -18. And then I have -4, 8, and 32. Here's my matrix. I press enter. I'm going to take reduced row echelon form of B. Gives me my answer right there. So it tells me that X is -2 and Y is 3. If I substituted -2 in for X, that gives me -6, and 3 in for Y, that gives me 12. So -6 minus 12 does give me -18. -2 times -4 is 8, and 8 times 3 is 24. So -8, positive 8 plus positive 24 equals 32. I was getting my positive negatives confused. Okay. Any questions on that? All right, so example 2 is solve a linear system of equations using matrices. So what is the solution of the linear system of equations? X plus y plus 2z equals 13, 2y plus z equals 5, and 2x minus y equals 6. So again, reduced row echelon form. It's going to be your best friend when you're doing anything with matrices, reduced row echelon form, okay? So the process of solving a linear system of equations using matrices involves using row operations, as was done in the previous example, to write the matrix in reduced row echelon form. In this form, the matrix represents the solutions of the equations in the system. So this matrix, this is a matrix in reduced row echelon form. It's a 3x3 system with a unique solution. Okay? So this matrix translates to an equivalent system of equations that tells you the solution of the system. So X equals A, Y equals B, and Z equals C. So you can write the solution as A, comma B, comma C, right? So that's basically what we just did. So the first thing that I want to do is I want to write this system of equations as a matrix. Okay, so X is 1, because we all know that there is a 1 in front of this X. It's an invisible 1. Same with the Y. There's a 2 in front of the Z, so the coefficient is 2, and then 13. There was no value for X, so you put in a 0, 2, and then 1Z equals 5, and then the last row is 2, -1, 0, 6, because there was no Z. Okay, make sure that you include the sign that's right in front of the coefficient. Okay, that will determine whether the coefficient is positive or negative. Okay. I then can go ahead and solve the system. Okay, to solve a linear system of equations using a matrix, I analyze and apply the necessary row operations to transform the matrix into its reduced row echelon form. So again, I can do this longhand. I can also plug it into my Desmos calculator, and RREF gives me the answer. Okay, so what they did was they took B minus 2 times A, and that became D. Okay. So they took B, which was up here. So here was A, and here was B. So they took B and they subtracted 2 times this first row, and that became D, which is down here. And then C stays the same. And then they took D plus 4 times C, and that became row E. Okay. And then they did E divided by 5, which became G. Okay, so now this row right here, this last row on the bottom, is in reduced row echelon form. Okay, so I know one of the values then. The value for Y is going to be 0. Okay, so I want to switch G and F. So H now matches reduced row echelon form. They just put it there because that's the middle value. Okay, then I'm going to take 2 times H and I'm going to subtract I. which becomes j. So now this is almost in reduced row echelon form. I want this to be a positive one, so I'm going to either multiply it by -1 or divide it by -1, so this becomes positive. Okay, so I multiply j by -1, which gives me the 1, 5. So now these two rows are now in reduced row echelon form. I'm getting somewhere. So now I need to figure out this top row, this row k. So I'm going to do k minus l, which gives me n. So now I have 1, 0, 2, 13. I need to get rid of this 2. Okay, so I'm going to multiply O by 2. So I take n minus 2O, which becomes P. And that gives me my new reduced row echelon form. So these are the exact same steps if we were solving linear systems of equations, just with less variables. Okay. Any questions on that? I went through that very quickly, so. No, okay. All right. So then, of course, we can check our solutions. Right, so the matrix shows that x equals 3, y equals 0, and z equals 5. So I substitute each of those back into my original linear equations, and they do all equal, so that the solution to my linear system of equations is 3, 0, 5. So I can then try this out. What is the solution of each linear system of equations? Write the matrix in reduced row echelon form to solve. So I'm going to go ahead and create my matrices. This one's going to be C. There are 3 variables. So we need a third row and 4 columns. So I have x plus y plus z, so 1 plus 1, 1, 1, 13. And then I have y minus z equals 3, so there's no x values, so 0, 1, -1, and 3. 0, 1, -1, 3. Okay. And then my last one is z equals 2x, so I need to move the 2x to the other side. So that gives me -2, 0, 1, 0. Okay. So here's my new matrix, matrix C. I want to do reduced row echelon form for this matrix. When I do that, it gives me x is 2, y is 7, and z equals 4. 2, 7, 4 is going to be my answer. And always double check, 2 plus 7 plus 4 does give me 13. 7 minus 4 does give me 3, and 4 does equal 2 times 2, which is 4. Okay. You do the same thing for this one right here. For B, x minus y plus z equals 5. Okay, so I need to add a third row and 2 more columns. So x minus y plus z is 5. And then 4x minus z equals 3. So 4x minus z equals 3. And then y equals -1. So 0, 1, 0, -1. And the nice thing is this last row is already in reduced row echelon form. They already told me that y is -1. So that's kind of nice. All right, so when I do this, I get x is 1.4, y is -1, and z is 2.6. I can always convert this into a fraction, really nice. So 7 over 5, 13 over 5. So my answer is 7/5, -1, and 13/5. 7/5, -1, and 13/5. You, of course, can always double check that your answers are correct by substituting them back in. -1 obviously is -1. 7/5 times 4, that's 28/5 minus 13/5. 28 minus 13 does give me 15, so 15 divided by 5 gives me 3. So that works. 7/5 minus -1, so +1, plus 13/5, so 13 plus 7 is 20. 20 divided by 5 is 4. 4 plus 1 is 5. So all of those answers are correct. They do work. 1.4, 2.6 are the same thing as these as well. Okay. You can use fractions or decimals, whichever one's easier for you to use. I personally like working with fractions. I know a lot of people like working with decimals. I usually convert all my stuff to fractions as opposed to decimals. So it's completely up to you, whichever way is easier for you, okay? Does anyone have any questions on either of these two examples? All right, so using technology with matrices, what is the solution of the system of equations x minus y equals z, 4x plus 3y plus 2z equals 6, and 2y minus x minus 3z equals 13? Okay. So again, I convert this to a matrix. I put it all into a calculator. It does it for me. Okay. So using graphing technology with a matrix function to input the system matrix, sometimes a calculator cannot display the entire matrix on the screen. I compute the reduced row echelon form, RREF, of the matrix using the function RREF. I can check my answer by substituting the solution that they give me back into the original system of equations, which is basically what we've been doing with Desmos this whole time. So what is the solution of the linear system of equations? X plus y plus z equals 55. It's really nice to do these on a calculator, especially with larger numbers like this. But it is helpful to know what you're actually doing and where you're getting the answers from. So matrix, add a row and some columns. So I have 1, 1, 1, 55, 2, -1, -1, -7, 1, 2, -2. Okay. Reduced row echelon form of matrix. So it gives me X is 16, Y is 18, and Z equals 21. I'll double check my answer by substituting it back in. For letter B, I have X plus Y plus Z equals 1.8, Z equals 2X plus 0.1, and 3x plus y minus z equals 0.8. So you have to be a little careful with this because we have the z equals 2x plus 0.1. So I actually need to move this equation around a little bit. So it's going to be -2x plus z equals 0.1. You don't have to do it that way. You could do 2x minus z equals -0.1. It'll give you the same answer. Okay, so all I did was I manipulated this second equation so I had the variables on one side and my constant on the other. Okay, I'm going to go ahead and create a new matrix. So x plus y plus z is 1.8. -2x plus z is 0.1, and then 3x plus y minus z is 0.8. Okay. Reduced row echelon form. And I get x is 0.4, y is 0.5, and z is 0.9. Again, you can change these into fractions. You can flip them back and forth, fractions to decimals, whichever one makes you happier. Okay? Up to you. Always substitute them back in, double check, make sure that they work out, because things happen. People input things incorrectly all the time. Always double check your answers. Okay. Any questions on that example? All right. So example 4 is in interpreting the reduced row echelon form. So what's the solution of the system? I changed this solution to this matrix. I reduced it. Yay. Notice that the output matrix from the reduced row echelon form function on your calculator is not in the form, okay, reduced row. There is an extra variable here. Okay, so 1, 0, negative 3 is 4, 0, 1, 0 is 0, and 0, 0, 0 is 0. Okay? So this matrix represents that x minus 3z equals 4, y equals 0, and 0 equals 0. So this set of equations has infinitely many solutions. Okay, I couldn't find a solution where x had a value, y had a value, and z had a value. Okay, so there's infinitely many solutions, which means I could substitute a lot of different numbers in order to solve this set of equations. That's what this means, okay? So if I have an x and a z or an x and a y, and I reduced row echelon formed it, but I have this type of thing up here, that means that it's infinitely many solutions. It doesn't mean you did something wrong, although double check and go back and make sure you entered everything correctly, but it doesn't mean you did anything wrong, okay? So the set of equations has infinitely many solutions. So thinking geometrically, this is kind of what this looks like. Kind of play with it. Drag and rotate it. Okay. So x minus 3z equals 4 and y equals 0 each represent a plane. Not like the plane you fly, but a geometric plane. Okay, so the equation 0 equals 0 is true for all points. 0 is always going to equal 0. Okay. So the graph shows that the two planes intersect in a line. So that means that all three equations are true for every point on this line. Okay. So here's my x, my y, my z. They intersect on this line right here, this black line. So they're true for everything there. So there are infinitely many solutions of this system. So if I have this system of equations, x minus 2y plus z equals 8, negative 2x plus 4y minus 2z equals 16, and x plus 2y minus z equals negative 8. I can go ahead and reduce row echelon form this. 3, 1, negative 2, 1, 8, negative 2, 4, negative 2, 16, and 1, 2, negative 1, negative 8. So if we look at my reduced row echelon form for this matrix, I have x is 0, y is 1, 1y minus 0.5z equals 0, and then 0 equals 1. Well, Can 0 ever equal 1?
No.
No. So that means there are no solutions. Okay. So I reduced for echelon form. There is a statement in this matrix that 0 equals 1. That's not true. We know it's not true. So there are no solutions to this system. Okay. You do the same thing for B. 0.9, 0.3. You do need to change that second equation. Matrix 0.9. 0.3, 0.6, 4.2. Okay, and then I have 6, -2, 4, 28, and then 3, -1, 2, 15. Okay. Reduce row echelon form. Oh, that's fun. These type of things, I really enjoy looking at them as fractions. It makes my head not hurt as much. Okay? So it says x minus 1/3 y plus 2/3 z equals 14/3, and then 0 equals 0 and 0 equals 0. Okay. Red flag right there tells me I don't have individual solutions for everything. So that means I either have infinitely many solutions or no solutions if I don't have one specific solution. So looking at this, 0 does equal 0, 0 does equal 0. That means I must have infinitely many solutions. That's fun. Any questions on either of those? Okay, example number 5, apply a linear system with 3 variables. This is basically everything that we've just been doing. It's just in a word problem now. So party planner charges customers based on hours, guests, and tables. A record of the invoices for the last 3 customers is shown. What is the per unit charge for each element? So Powell birthday was 3 hours, 20 guests, 4 tables. Total was $370. A retirement party was 4 hours, 35 guests, 2 tables, and $560. And the wedding was 6 hours, 75 guests, 16 tables for a total of $1,130. So the first thing that I want to do is I want to assign a variable basically to each one of these. So hours, guests, tables, HGT, kind of makes sense. And then my total amount. So when I do this, 3H plus 20G plus 4T equals 370. 6H plus 75G plus 16T equals 1,130. And then 4H plus 35G plus 2T equals 560. So when I do this in reduced row echelon form, because it makes me happy, H equals 50, G equals 10, and T equals 5. I can, of course, substitute all of these values back in, and they work. Okay. I can then interpret it. So the hourly charge is $50. That's what the H means. The G represents the number of guests. So it's $10 per guest, and then 5 per table. So $50 an hour, $10 a guest, $5 a table. All right, so when I'm dealing with number 5, a student has $128 in its savings account. If she were to withdraw the money and was only given $1, $5, and $20 bills, how many bills of each denomination would she have? Assume she has a total of 28 bills and she has 3 times as many $1 bills as she does $5 bills. So I'm creating 3 different equations. So I'm going to say O equals $1 bills, F equals $5 bills, and T equals $20 bills. Okay. So I'm going to create 3 equations. I know O plus F plus T equals 20. Okay. And then 1O plus 5F plus 20T equals 128. And then 3 times as many $1 bills as $5 bills. So 3F equals O. But I need to solve this so there are the 3F and the O are on the same side. So I'm going to take -1 O plus 3F equals 0. So when I create this, 128, 128, and -1300. Okay, I reduce row echelon form. I get 18 $1 bills, 6 $5 bills, and 4 $20 bills.